So I'm just going to do a quick intro. So my name is Amy Rowe. I am a software engineer here in Dublin's Tech Hub. And I started Mastercard as an intern in 2018 and got offered a position on the graduate program in 2019. So since coming back, I've been offered roles on the intern committee and the university engagement committee. And along with my colleague, Shauna Nocton, we organised Mastercard's presence today at System. So I'm just going to give a little intro to the talks and then we can get started. So first up, we have Dr. Steve Flinter. So he heads up our artificial intelligence and machine learning group here in Mastercard Labs. And today he's going to discuss quantum computing. So I know, very big words. Quantum computing uses the laws of quantum physics as the basis of computation and has the potential to be able to solve much more computationally complex problems than a normal computer can. So Steve's going to give a demo today of a simple problem running on an actual quantum computer, which I'm really excited to see. Next up, we have John. So John Conneely is a project manager here at Mastercard, and he manages the business operations for Simplified Commerce, which is the Mastercard Payment Gateway Services small business solution. Outside of work, John runs Young Leaders in Tech, which is a meetup group and podcast that provides information on how people can improve their leadership skills through panel events and tech industry interviews. Lastly, we have Tansy Murray. So Tansy is the Vice President of the Product Experience and Design team here in Dublin. So with a career in design spanning almost 2 decades, Tansy's mantra is that good design is good business, and it's critical for driving innovation, differentiation, and great customer experiences. She believes that shifting how organizations think about design is key to delivering successful products. She strongly believes that the key to an organization's success is to design products that are transformational, impactful, and lastly, equitable. So, Cian, I'm not sure, did you have anything to say, or can we just get straight into the talks?
No, I just the only thing I have to say is just thanks very much for coming along and being part of the conference. We're delighted to have you here. And yeah, so take it away, please. Thanks very much.
Thank you so much. Okay.
Cool. Okay, so I think I'm first up. So let me see what all the tech play ball with us. Let me share my screen. Okay, hopefully that's coming through okay. Cian, does that look good from your end? Cool. Okay. So thanks, Amy, for that great introduction. Thanks, everybody, for taking the time to join this session. As Amy said in the intro, I head up the AI and ML group within Mastercard Labs here in Dublin. But today I'm going to talk to you about quantum computing. And I want to give you an example rather than kind of present you with a whole bunch of slides. And so what I'm going to do is to give you an example of how you can use a quantum computer to solve a logic puzzle. Now, needless to say, this is kind of overkill. You don't need a quantum computer to solve the puzzle we'll walk you through, but hopefully it'll give you some intuition as to how we can set up these problems and the types of much larger problems that we may potentially be able to run on quantum computers. So the example I'm going to give you is the type of thing you might see in a newspaper or a logic puzzle book. Some of you folks may have seen it, and hopefully you can read the description, but let me run through it very quickly. So you can see that there are 5 people here, A, B, C, D, and E. So Armand, Basil, Carton, Dunwood, and Everett, who are members of a polo club. Each owns a pony that's named after the wife of one of the others. And apologies in advance for the slightly non-PC nature of the setup, but it's an interesting puzzle, which is why I chose it. And then you can see there's a bunch of clues here. So Alloway's pony is named Georgette, Cunningham's pony owns Jasmine, and so on and so forth. And so what we have to try and do is to take these clues and work out who is Jasmine's husband and who owns Helen. So that's our setup here. And this is an example of what's known as a satisfiability problem. And for anyone who does Sudoku puzzles, that's another example of a satisfiability problem, where essentially there's one unique solution that will satisfy all of the various clues, and then there's many, many, many wrong solutions. And so our challenge is, how do we find that right unique solution? Okay, like so many things in computer science, half of the challenge is trying to understand how do we set the problem up. So this particular problem, we have 5 men, 5 wives, and 5 ponies. So essentially we can set this up as a 5 by 5 by 5 grid. And what we're trying to do essentially is in each cell of this grid, assign either a 1 or a 0. And a 1 in this case indicates that we think that this 1 is part of a valid solution, and a 0 indicates it's not. So we can see on the left here, this is the kind of the basic setup, and on the right, we see we've put a 1 in a particular cell here. This is the cell that corresponds to man D, wife I, and pony F. So essentially, this is saying that we believe that man D is married to wife I and owns pony F. And by definition, then none of these other assignments are part of the solution. So our job essentially is to find a way to label each of these cells with a 1 or a 0, such that all of the constraints that we had above are valid. Okay, so we're going to run this for real. So this is a Jupyter notebook. If any of you guys have done any data science work before, so we'll step through all of this piece by piece and actually run it. So first we need to kind of set up some mappings. This is the letters of the initials of the people to numbers, because we want to work with numbers rather than letters. Now, the first step we need to do is to set up some global constraints. So what we mean by that is we need to be able to find a way to represent some of the obvious rules, like the same man can't be married to 2 wives, or the same man can't own 2 ponies, or the same woman can't be married to 2 husbands. And we do that essentially by setting up constraints that talk about the sums across different pieces of that structure that we had, that 5 by 5 by 5 structure. So here, for example, you can see from the first slice of that cube that we had before, this corresponds to just the possible assignments to pony F. And you see we have, again, just that 1 in one particular cell. So the sum of all of these cells comes to 1, and this is a potentially valid solution. If we ended up with an assignment like this, you can see that the sum of these sets of cells comes to 2, obviously, because we have 2 1s. And this would correspond to the fact that a single pony F is actually owned by 2 people, by man C and man D, and clearly that's not valid. So this is kind of how we go about turning these natural language rules into something that we can kind of work with computationally. So this cell here essentially sets up all of these constraints along various slices. Next, what we want to do is to look at what we call local constraints. So this is kind of back down to the individual clues that we got at the start of the puzzle. So I'm just going to do one and explain it in a bit of detail, and then we'll kind of skip through the rest fairly quickly. So the first clue we had was Mr. Alloway's pony is named Georgette. So really what that's telling us is that for the slice of the cube that we set up that corresponds to Alloway with pony G, Georgette, we know that one of those assignments for the wives must be valid. So we know that the sum of that column or that vector through that structure has to be 1. So we don't know which one of these cells will have the 1 yet, but at least one of them have to have. And then by definition, the other corresponding pieces in the various slices must be 0. And again, this is how we kind of establish the rules for individual constraints or individual clues like this. So the next line in our code does exactly that. So here what we're saying essentially is we're putting a sum equals 1 constraint on the index of A, which corresponds to the man, Alloway, and the index of G, pony G, which corresponds to Georgette. So somewhere along that slice, the sum of those must be 1, and by definition, everything else must be 0. So that's kind of how we set up these local constraints. And we can use essentially the same structure for all of the other constraints that we were given, or all the other clues we were given. So Colonel Cunningham owns Jasmine. So again, we have man Cunningham and Jasmine, and there must be a 1 along that particular slice. So I'll skip through the rest of the clues fairly quickly in the interest of time, but it's the same basic setup for all of those. Okay, so we kind of go through all of the various clues that we had. And now we're going to actually get to something. All of this is kind of running locally. This is running on a traditional computer. There's no quantum involved in any of this stuff yet. So now we're getting to the quantum side of things. And as you're kind of guessing as I go through these examples, I kind of went into computer science because my career as a visual artist was never really going to work out. So here's the kind of the last crude hand drawing I have. But this hopefully gives you an idea of what's actually going on when we build up all of these structures. So we're going to run our program on a quantum annealer, but a quantum annealer doesn't accept a program in the way that a kind of a typical computer that we would understand it does, where you kind of start with some source code, you run it down through a compiler, and you end up with machine code. So a quantum annealer is a device that's specialized to find optimal solutions of things. And really it accepts a matrix of numbers as its program, and its job is to then find an optimal solution which corresponds to the lowest energy of that matrix. So in the diagram here, if you can imagine, we have a two-dimensional solution space, and imagine each of these dots in my space is one possible solution. So one possible assignment of ones and zeros to all of the that 5 by 5 by 5 cube that we showed at the start. And then if we can further imagine that we have a kind of a landscape above that surface, and depending on how high above the surface you are, that corresponds to how bad the solution is. So higher energy corresponds to bad solutions, low energy corresponds to good solutions. So this is meant to kind of depict a mountain range, if you like, with kind of peaks and valleys. And what we're trying to do essentially is get the quantum computer to find the lowest point in this entire surface. And the lowest point will correspond to the correct solution. So that's kind of the setup. That's what we're trying to get to. So to do that, we need to then plot this as a matrix of numbers, as I mentioned. You can see here the matrix is 125 by 125. We also put it through a step where we reduce the number of variables that we have, which is necessary because the modern day or the current availability of quantum computers are not hugely powerful. Although this problem is not terribly complex, we could run it with all the variables. But as we scale up to industrial size problems, we can't. Okay, so that's the kind of setup, and this matrix, this is a kind of a visual representation of the matrix that's sent into the quantum computer to get it to solve. So let's go ahead now and submit our job. So the quantum computer itself is owned by a company called D-Wave, and the way it works essentially is let me do a refresh here. We submit a job to an API that is sitting in front of the quantum computer. So this is essentially a process where we don't own the device ourselves. We submit the job, it's queued, that job is pulled off, the program or the optimization job is run, and then we get a result back. And this is typically how quantum programs are operated. That we don't see companies like Mastercard owning these devices. We'll access them over the web. Okay, we can see the job that we've just run is complete. So if I go back to my notebook here now, I should have a request ID, and I should be able to now look at the results. So the results come back as this array, and you can see the array has the assignments that we're looking for. So we've ones and zeros in all the boxes. These 5 by 5 structures correspond to man A, man B, man C, D, and E. And then the rows in each of these correspond to the wives. So the first row corresponds to wife F, right down the line, second row, wife G, and so on. And then the columns are the ponies. And so what we want to do is just to kind of turn this into something a bit more readable. So we'll just kind of process that, and we end up with this grid, which basically says that our solution, as the quantum computer identifies it, is that man A is married to wife F and has pony G, man B married to wife I has pony H, and so on. And so we can kind of verify by hand that all of the rules, all the puzzle clues that we were given are satisfied. And then once we do that, we can kind of answer the original questions that we were given. So who is Jasmine's husband? We can see that Jasmine's husband is Dunstan. I've just written about it in words here, but it's the same in the actual computer table. And who owns Helene? And Helene, the pony, is owned by Bennington. And again, we can see the computed answer, Helene is owned by Bennington. So that hopefully gives you in about 10 or 12 minutes a whistle-stop tour of how we can use quantum computing to solve these kinds of optimization problems. Now, as I said at the top, this is a very, very simple problem. This is designed to be solved by pen and paper, but we can scale up these satisfaction and constraint and optimization type problems to be much, much harder problems, ones that we can't even solve with clusters of GPUs, never mind solve by hand. So hopefully that gives you a very brief intro of what this is all about. Feel free to drop me a line if you're interested in this kind of stuff. I know this is only kind of 15 minutes and I had to rattle through it very, very quickly. But if there's interest out there, I'm more than happy to set up an office hour session after the fact and maybe dive into this stuff in a bit more detail. But with that, let me hand over to our next speaker, who is John. And if we have enough time at the end of the session, I'm very happy to answer any questions that anybody has. So thanks for your attention. And John, over to you.
Cheers, Steve. Let me share my screen. Let me know if you can see that.
Yeah, coming through for me.
Well, good. Okay, perfect. Let's go. So I'm John Conneely. As Amy said, I'm the product manager, not the one, at Mastercard. And I also run a podcast and meetup group called Young Leaders in Tech. Today, I'm going to let you know some of the information around how I went about setting it up and how you could do it yourself if you wanted to. So one thing you may not think about when you're naming the podcast, the most important thing is that whatever name you come up with might have a limiting factor on it, something that makes people think it's not targeted for them. I didn't realize that mine did before I thought of it, but before we get started, I'm going to leave this quote here. Anyone who stops learning is old, whether 20 or 80. Anyone who keeps learning stays young. So it's a popular one from Henry Ford, and it's the answer that I've had to paraphrase quite a few times to people who have asked me, I'm too old to go to this meetup, or it's only for young people. I give them this, and that's their assumption, but it's not the case at all. So just set out with that one. But just one thing to note when you're thinking of the name. So the first podcast I did with a couple of people who are experts in storytelling. So the lesson that they taught me was to not rely on your slides to provide the information you need to get across. The other thing that taught me was the technique of why, how, and what. You want to be able to answer these questions about whatever topic you're trying to start for. If you can't answer these, then how are your listeners, your viewers, or your readers supposed to understand? So you start off with the why. This is your purpose. Why do you want to do this? You'll move on to the how. What actions you want to take to make this, the why, a reality? How can you do it? Then you'll finish with the what. What is it that you do? This is going to be the result of the how, or the why. I'll speak on these and what mine were next. So start with the why. What is your cause? What is your purpose? Why are you doing this podcast? Why do you want to start a meetup? Why do you want to start a blog? What is it that you want the listeners to find out about? So there's a lot of things. There's a lot of obvious things like becoming a better presenter, building your self-confidence, which obviously in any professional environment is a huge bonus. You've got the networking aspect, but there's a lot of other things you might not think about when you're starting down this path. Would you like to become a subject matter expert in an area? Do you know very little about a topic, and would you like to know a bit more? I learned very quickly that I knew very little about the things that I was asking my speakers, but it's your questions and the way that you ask them that'll inform you and your listeners, and in turn help everyone else learn more about the topic you're trying to talk about. So my reason, about 80% of it was what's written on the screen here, but the other 20% was somewhat a form of jealousy. So a friend of mine had started their own meetup called Indie Hackers, sponsored by Stripe, and as a result of this, he got to interview the Collison brothers. So I was sitting there watching it, and I was like, wow, I could do this. How can I get to meet people like this? The problem I had was that I wasn't particularly adept at anything in general. I came from a civil engineering background into tech. I did a 1-year postgraduate course in computer science, and that's all the experience I had in programming. So I knew a little about a lot of things, but not a lot about anything. What I did know was that I was trying to move into a leadership role in Mastercard and become a team lead of some sort, but I didn't know how to get there. I needed some advice and tips. But of course, any course I found or any leadership training was super expensive, like €300 or €400 for a few weeks. So I didn't want to do that, obviously. So that's what made me want to start mine. Next, we got the how. How do you do it? How do you, for want of a better word, manifest your why? How do you make it happen? So the bare minimum is something like this. You need this for, I'm only joking. That's not it at all. All you need is a computer of some sort, access to the internet, and a way of recording your voice. That's pretty much it. A lot of you might have already got headphones with good speakers in them, like the likes I have here. This is good. You may pick up after a little while, you feel like you're ready to pick up a microphone. This is what I have. I use this one. I'm using it right now. The microphone's really clear, and it's not that expensive. It's around 50 quid on Amazon. One thing to note, and you'll probably learn this the hard way, like I did, avoid Apple products for microphones. They have really good sound quality. Their microphone quality is really not up to scratch, and you'll spend a lot of time trying to edit the harsh S sounds from your audio files, which is really annoying. If the next step you think you're starting up a podcast, you're starting up a meetup, you go on to Google, what do I need? How to record a podcast? They'll give you all sorts of advice, all sorts of software that you need for podcast and streaming. A bunch of solutions that'll do way more than you need at the start. These are some of the ones I've used to varying levels of success. Now, granted, I still use Audacity. It's free. It's fairly easy to use, and it's really good for editing audio files. But yeah, basics, what you need at the very start is Zoom, essentially. When you record a meeting in Zoom, it saves it as a video and an audio file separately. So that gets rid of the work involved with taking the audio out of video. That's it. It's really good quality. It takes very little effort after that to have your recording ready. If you're not any good with Windows Medium or Movie Maker, or if you don't have a Movie Maker app, you can literally just trim the audio file in your WhatsApp or in Telegram or whatever, and there you have it. You have your recording. So this leads me on to the next section of the how, and that's how to not get knocked down when things go bad. Don't get stopped by problems. When I started the meetups, I reached out to some hotels and bars to see if they had some function rooms. I chose Tuesdays as that's the day that I thought that was the pubs were most likely to be empty. I was most likely to be able to get a free room. And it was also the day that people were least likely to have other plans so that they could come to my meetup. What I didn't know is that it seems to be the day with the worst weather, or so it seemed to me anyways. My first meetup, I had 3 people. That jumped to 5, big numbers on number 2. And then for the third one, I had a red weather warning. So I was sitting there 20 minutes after it started with nobody turning up. So I had to cancel it. These things happen. You just have to kind of power through. But as part of that, to protect myself against the Irish weather, I started to live stream the meetups. I initially started with Instagram and then kind of started trialing out LinkedIn Live, but that brought more problems. This meetup here, this was a great meetup in the Bank of Ireland studio in Trinity, which, by the way, is another free venue you can book. And it was my first one to stream to LinkedIn. On a side note, if you are looking for meetup space, just look at other meetups in Dublin or whatever region you're in where they're booked, probably free. Contact the event or the venue and see what they have. But this one here, this is the first one I did live to LinkedIn. The previous few were on Instagram, but it's on your phone. It's not great for watching meetups for an hour, so I wanted it on the desktop. Everything went great. The meetup was really entertaining, and then I checked my laptop to see this. No sound. Great. Yeah, not what you want to see after an hour talking. Luckily, I had backup plans in place. I had a dictaphone recording in the room. They're cheap, like $10 on Amazon, and I was able to use that sound to the video I was recording. So it's always good to have a contingency plan. But I was saying, once you have all these difficulties, as long as you persevere and keep going, you'll eventually end up with a finished product, something that you have created and something that you can be proud of. So that brings us on to the what of the whole thing. What is your product? What is it that you have done? What are you proud of? Make sure you're not locked into one idea. Make sure that you are able to change your plans or product if a part of it isn't working. For me, I started out thinking a bunch of people who are on the same boat as me, who wanted to go discuss how we can become managers, would just sit in a room and talk about it. Now, looking back, that was obviously not the right path. And it sounds a bit stupid as I'm saying it right now. It took me inviting one of my former co-workers along. I knew she was good at public speaking. She had been a panelist at a number of conferences. So I asked her to come along and give advice to the people at the attending, as she was already a leader in her field. This was the one on the top left. So because of the success of this meetup, everyone was really happy with it. I realized that this should be the structure of my meetups going forward, Q&A with people who are in the situation that we're looking to get into. So people with experience and people that we want to learn from. It's obvious to me now, but again, with your own plans, some of these things may not be obvious at the time. So you need to be okay with a change in plans if something happens that makes that plan need to change. Then COVID happened. Just as I had my biggest turnout for an event, we went into lockdown, and the meetup I had planned for the end of April last year obviously couldn't happen. So I had to pivot really quickly and make it virtual. In my head all along, I kind of knew that I should have been like uploading these as podcasts, but I never really saw the necessity to do it as the meetups were going really well. So once COVID hit, I really had no excuse. So I had a list of contacts that I built up from my meetups, and I started reaching out. Another slight segue, just keep a spreadsheet of everything you do, your speakers, their contact info, any emails you've sent, save the text so that you don't have to type it up each time. Any questions you've asked, save them in a list. They might inform some other questions. You can use the same questions again in most cases. This is really useful stuff, having it in one place makes everything way easier. So back to some of the speakers that I had on for the panel discussions had speciality areas that they were trained in and made them perfect for the podcast. Others I found simply hearing them on a different stream and dropping them a message on LinkedIn or Instagram. You'd be really surprised at how many people want to join you on a podcast to talk about what they're passionate about. Don't be afraid to reach out. The worst they can say is no. I would advise, though, to start small. Don't go for your idols first. Don't be reaching out for the Bill Gates and Elon Musk before you get a bit of practice and experience. Look for the people in your company or lecturers in universities. They're usually glad to help. And then once you've refined your process, then you can start reaching out to the more elusive speakers. As I said earlier as well, if you're part of a company or even in university, you may be able to get some funding for event spaces or for finger food, small things that will entice people. Mastercard were really good with me. They gave me support from the very start, and they helped me get the word out, as well as giving me some help to buy food at some of the events when I needed it. It really can't hurt to ask. But at the end of the day, you are the glue that's going to hold whatever you come up together. You are also the what. You're the driving force behind whatever podcast or meetup you come up with, and you should make sure that people know who you are. Don't be afraid to let people know what you do, your background. Let people in your company know what you're doing, your blog posts, what made you decide to go down this road you are on. With that in note, I'm going to do my own shameless plug here, and I'm going to leave this here. So if you are starting down this route, please give me a shout on LinkedIn. I posted my link earlier. Add me on any of the links up there above. I'd be glad to help out on any tips, any equipment, recording software you need to get up and running. I trialed most of it. You should find me easily enough on LinkedIn, so don't be afraid to drop me a message. And that's all from me. Over to you, Tansy.
Awesome. That was fascinating, John. Thank you so much.
Close this now.
Definitely be reaching out to you. You have my slides there, John, and I have a couple of fabulous assistants today. Chloe, are you in the chat room there, ready to go with some polls in a moment? I'll let you just respond. So while I hope Chloe is responding, let me introduce myself. Okay, we're good to go. Fabulous. Thanks, Chloe. So hey, I am Tansy. I am the Vice President for CX and Design at Mastercard. I have a team of front-end developers, designers, content writers, animators, videographers, all of whom come together to build products that are transformational. That's what we're aiming for. Transformational, and where we can be equitable. And so it's a super exciting role. I absolutely love it. But what I wanted to talk to you today about is how design and software development come together. So in other words, how research, design, and tech, the perfect triumvirate, come together to create great products. And we're going to have a look at a few different companies and how they managed to do that by bringing in those three really important and interconnected disciplines. But first, let us have a poll. Next slide, please, John. So we're going to test your knowledge. What I'd like to know is this good design or bad design? You can tap on the poll there and you'll see an option, good design, bad design. Mastercard folk, love you to vote as well. This is the suite of Google icons, the recently redesigned Google icons. You will obviously recognize Google, Gmail there, Maps, etc. But what I want you to tell me is this good design or bad design? Go ahead and vote. All right, I've got 55% saying good. I've got 45 saying bad. What's the answer, John? This is bad design because visual design harmony was prioritized over user experience. In other words, they look great, but they're very, very hard to tell apart. If you've been using one beside the other on your phone app, it's really hard to figure out which one is the other, and you keep pressing the wrong one. So in other words, the user experience team were trumped by the visual design team. All right, next one. Yep, that will reset. Marvelous. All right, so while that poll is resetting, let me just give you a little explanation as to what you're looking at. You're looking at a lift, and there's regular up and down buttons like you'd find in a lift normally, but there's also these kick buttons at the bottom, and up and a down button. So if we can get that poll refreshed, Chloe? Okay, it should be coming. Is this good design or bad design? Vote now. Interesting. Lots of folk on bad design. Good design coming up. All right, let's wrap that one. So 58% think it's bad design. What is the answer, John? This is good design because it is designed with what's called affordance in mind. Affordance is super important in design, whether it be industrial design, UX design, visual design. You need to give affordance. In other words, you try to make people's lives just incrementally easier when you're designing. And the designers of the lift put in a kick button that would allow you to hit the button if your hands were full, if you're carrying a baby, or if you just didn't want to touch a COVIDy button. That is affordance in design, super important. All right, next one. Let's see if we can get a good answer on this one. All right, so we're looking at a subscribe to a newsletter. You will have done this a million times. So subscribe to this newsletter. Is this good design or bad design? Take a look at it there and vote. Ah, yes. All right, we're getting it now. This is bad design. 89% say it's bad design. And the reason, John? The lack of information hierarchy, and it creates unnecessary confusion. Hierarchy is so important in any kind of design. So good design separates the signal from the noise. All right, next slide, please, John. All right, so while the poll is resetting there, let me explain what you're looking at. This is a public restroom, and you're looking at the sinks in a public restroom, and one is higher than the other. So there's one down low, one up high. Good design, bad design? All right, votes are coming in. I like it. We're firing now. Good design. Absolutely, this is good design. And the reason, John? Because the design considers all users, not just able-bodied adults. So when you create a design that is nice and symmetric and perfect and everything is at the same height in a bathroom, well then because it looks nice and all of the angles are nice, it actually means you've designed children and people with disabilities out of using that bathroom. So sometimes how things look has to come second to their functionality. And in this case, the functionality is much more important than whether or not your sinks are all aligned at the same level. Next up, John. Yeah, you have to look carefully at this. This is an interaction design. So what's happening here is somebody is saving. So they're hitting that save button. It's taking a couple of seconds and eventually it turns to saved. You'll see it just change to saved in a moment. Well, believe me, it does. So you hit save, it takes a few seconds, nothing much happens, and then it turns to saved, a saved state. Good design or bad design? All right, fairly evenly matched, but again, we bad. Oh, good design. Just one. Just beat the bad design next. Oh yeah, okay, even split. This is bad design because good interaction design is crucial to user comprehension and trust. You can see in the example below that it says saving. So when you hit the save button, it should move to a state of saving, even if there is quite a bit going on in the background, rather than leaving the user going, do I just need to keep clicking? Do I just click, 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 click? Or is there something actually, a process happening in the background? And by changing to saving, the user knows that they don't need to keep clicking, it's going to save. Next one, John. All right, this is the final one. Pay careful attention to this image. This is a park bench. Pay careful attention to what is under the park bench. Good design or bad design? All right. So indeed, this is bad design, putting your water fountain under the park bench, unless, of course, you were looking for a free butt wash. But in this case, I'm going to assume that you weren't. So we've looked at so many different types of design there. I've gone through environmental design, interaction design, industrial design, UX design, visual design. So what do they all have in common? What does design mean anyway? And next slide, John. So design is a human-centered approach to solving problems. I think people run into the trap of thinking design is how things look. Yeah, that's part of it. But how things look is immaterial if they don't actually solve a problem for the people that you're designing for. And that is so evident in, you can see it in so many different pieces of work where people have designed something because they thought it was a good idea, but they had no idea really if it was solving pain points and unmet needs in people's lives. So if we take a step back and think just how big design is, design includes research. So it includes qualitative and quantitative family and friends research, includes evaluative research, and then it includes all of the different disciplines of design depending on what you're designing, but assuming it's going to be some software product with a UI, then it's going to have UX design and visual design. And then of course you've got your all of your technology partners, so you've got your front end dev, back end, etc. So next slide please, John. So who needs to be in the room for good design to happen? And next slide. And just hit it again there, John, just one more time. There we go. So we often think about product development as a software development problem, essentially, don't we? We think about it in terms of the technology because the technology is so hugely important, but it's only one piece of the pie. When you're designing successful products, and I'm going to get into talking a little bit about successful products that we will all be familiar with, you need to think about having all of these people in the room. There needs to be research. That could be a quant evaluative. There needs to be someone who's setting a strategy. What is the experience strategy for this product? What is it what are the pain points and unmet needs that we're really trying to solve, and how are we going to build our product roadmap around solving those problems? Obviously, you need design. You need UX design if it's going to have a UI. You need user testing, so you're going to need to do usability testing, etc. Of course, you need your front-end dev who's going to work closely and understand all of the problems that you're trying to fix, rather than just understanding the technology. And then, of course, your front-end and your back-end need to be in complete harmony and understanding what it is that we're trying to do in the first place. So next slide, please. So all of these people matter because it's so important to design the right thing before designing and building the thing right. And there's something about human nature that just really loves to rush to the designing and building stage without ever really putting in the effort to make sure that they're designing the right thing in the first place. It seems so tantalizing to go, I've had an idea, I'm going to go and build it. When actually, if you spent just a little bit of time on that upfront research, and if it's in the case of building your own products and you can't afford qual and quant as you would in a large organization like Mastercard, friends and family research is where you should start. It is phenomenal the amount of information you'll get from friends and family. So making sure that before you jump into technology and before you jump into design, that you actually know that you're solving pain points and unmet needs in people's lives. So let's have a look at some companies who do that and do that really well, that triumvirate of research, design and technology. So Airbnb, Obviously, incredibly beautifully designed product, works incredibly well, fabulous UX, works for all of their user types, whether if that be somebody who is trying to book a holiday or somebody who wants to put their home or their room and make it available for rent. But everything that Airbnb do is built around the human experience. They invest heavily in research, and they use their research to give them the signals for what to design and what to build. So, and all of their innovation is grounded in research. Next up, John. Google. So Google is about understanding behaviors at scale and using those insights to drive design decisions. So monitoring every click, every movement is how Google and many of your your digital giants constantly iterate and constantly make their products perform better by paying attention to what their consumer or their user is doing. Next one. Amazon looks bloody awful, but everyone uses it, and just shows you that visual design doesn't trump the usability here. It hasn't really changed in years, and yet obviously everybody uses it every day. Incredibly successful because their UX is wonderful. The visual design leaves a lot to be desired, but it doesn't seem to matter because you're able to complete your task. You're able to get what you want. And they release a new production code once every 11.6 seconds, which is staggering. But what that means from a consumer research point of view is that consumer delivery, continuous delivery makes continuous research possible at the same time, so they can constantly optimize their performance based on how their users are responding to every page. Next one, John. And Netflix, very similarly, Netflix transformed how we consume entertainment and has completely disrupted the traditional TV industry because it responded to pain points for consumers and had built a system around eliminating those pain points. We always just assumed that we had to put up with the pain that is advertising. It was just, that's how it was. And Netflix came along and said, no, you don't. There's a different way. There's a different approach. How can we solve that pain points for consumers? Well, perhaps they prefer to pay, not to watch ads. Turns out they did. And next one, John. So finally, Tap on Phone, a Mastercard product that I am very proud to have been a part of. And when I say design is transformational, this is a really transformational product. Essentially, it can turn any mobile phone into a payment acceptance device. And so when you look at the major use case for that in small business or small and micro merchants who wouldn't be able to afford perhaps expensive point of sale equipment, can actually use their own phone to accept payments rather than having to turn down payments from people who don't accept card or digital payments. And so it makes a huge shift for those businesses, and essentially democratizes access to design and technology have come together to create something that moves the needle and is completely different. So finally, just to wrap up, so the message is good design is human-centered and good software development is human-centered too. All right, thanks everybody. I'm done, Amy.
Okay, perfect. I'm not sure if we have any time for Q&A, but if anybody wants to hop on to the our booth is under the Expo tab on the left-hand side of your screen. Maybe these guys are going to hop on for a couple of minutes to answer any questions you might have.
Yep, happy to.
Yep.
I'm not sure if Kian or Adam or Chloe wants to say anything, or if we can just.
Cheers, folks.
Thanks, folks.
Yeah, no, nothing in particular to say there. Just again, big, massive thanks for coming along today. Really, really interesting chats there. So it was great to hear from all of you. So really do appreciate it. And I hope you guys enjoyed being here today as well, because you've definitely added plenty to the conference. So hopefully we added a bit to your day too.
Certainly
Cool.
did.
No worries.
All right.
Thanks,
Thanks,
Kane.
Kane.
Cheers.
Folks.
Bye.
No problem. Thanks very much.
Talk to you later. Bye.